Good morning, everyone. My name is Melissa Taylor. I'm the National Product Manager at Graybar, and I would like to welcome you to Graybar's G2 Talk presentation on Public Safety, America's Lifeline. This talk is part of a webinar series we offer each month for our data communications customers. We have a great discussion lined up for you today, but before I get started, I'd like to cover a few housekeeping items. First of all, if you were one of the first 50 people who joined in on this presentation, you will receive a coupon for a free cup of coffee courtesy of Graybar as a thank you for your time today. Also, at the bottom of your screen, you'll see a box for Q&A. Free to submit questions throughout the presentation. We'll address as many questions as time permits at the end of the presentation. Lastly, our G2 Talks are all archived on the Graybar.com website, so you'll be able to view this presentation again or recommend it to others. We are happy to team up today with Solid. As a data communications distributor, Graybar is working alongside Solid to help build our wireless future and protect our communities through innovative solutions that ensure wireless service anytime and in any place. You can visit Graybar.com to learn more about our solutions. At this time, I'm happy to introduce today's speaker, Bob Murray, Director of Strategic Accounts at Solid. In his role as Director of Strategic Accounts, Bob is responsible for defining and executing the company's distribution strategy and public safety focus in the U.S. and Canada. Bob is responsible for many of the company's largest public safety transactions, including the Stanford campus, Sutter Health, Providence Health, Amazon campus, Nintendo, and many other marquee projects. He possesses more than 15 years of experience in the wireless industry, with 7 years focused in the distributed antenna systems market, or DAS. Prior to joining Solid, Bob focused on wireless security technology for devices used by our military in the Middle East. Bob is a member of several public safety APCO chapters as well as the Safer Building Coalition. So without further delay, I would like to turn the presentation over to Bob. Bob?
Thank you, Melissa, and good morning, everyone. I wanted to bring up several different slides today. Some of them are going to be talking about public safety codes, on where to find them, also different resellers that would be in the industry that understand what's needed, also to the building owners as far as things to look for, and just primarily talk about the public safety market in general, but also I'll give you some very specific slides on the codes themselves today. You do have an opportunity to write some questions as we go through these slides, so I would encourage that, and then we can tackle those at the end of the presentation. My first slide that I have up here is one that is kind of a marquee slide for Solid Technology. We do build DAS equipment. We're very much into the public safety environment and belong to a number of different chapters that focus on why to have public safety, the different buildings, and the challenges in each of those as well. And as you look at this slide, and you can see that this is a large city with lots of different buildings. And if you talk to a fire chief, he could tell you every one of these buildings that has poor coverage in it. And that's basically based on 40 years of experience or more of generation after generation of firemen that have gone into the same buildings knowing full well that their radios don't work. So I'm going to talk to you a little bit more about that. I did want to take you back in time a little bit. First, not to move forward, but to go back and just to show you some of the things that public safety used to look like, and the simplicity of a town back in the Wild West, where basically the sheriff's office was simply one person, maybe and a deputy following close behind. And it's interesting that they're still carrying guns today, and for obvious needs. A quick look at the firemen in this particular scenario. If you've seen many Westerns, you know that basically the firemen were the people in the town, and that when the fire broke out, everyone would relay the message that a fire was taking place. Everybody lended a helping hand, and bucket by bucket they were trying to put out the fire. But in many cases it was just too little too late. As time wore on, fire, word of mouth was still the same. In 1930, the invention of the telegraph came along, which expanded communications along railroads and roads that stretched from town to town. And the telegraph quickly found its way into the fire and the police stations for quicker responses for help. Eventually, the telegraph was used across country and even across the oceans to communicate. Was moving data faster as well. We can look at the teletype. When you look at the lady on the left, she's actually tapping Morse code there. It was the language of the operator as a means of communication. And if you look at the center, you'll see the men were putting telephone poles up, or I should say telegraph poles up, for the very first time in history. And obviously there's a wire that needed to be strung across it from town to town and eventually from one side of the nation to the other. A short time later, actually, in the last picture over here, you can see that the man actually has a headphone on and he's decoding the Morse code. And a short time later, in 1960, the telephone came out. So you can kind of look at Morse code as being texting. And then the telephone came out in 1860. And the big challenge there was to actually build the infrastructure for the telephones. Much like today when the carriers first came out with wireless phones, the infrastructure across the U.S. had to be created as well. Ironically, during that very same year that the telephone was created for communication, the Pony Express started as well. And the repeater rifle was also invented at that time. This next slide, in 1952 in Boston, they were the first city to enforce what's called a call box. And the call box on the far left was something that you had to break the glass. It says on the front, break the glass, open the door, pull the handle once down, and let go. And as soon as that was done, the fire department was notified. And that call box had an identifier in it as far as where that person was requesting fire assistance. In the middle section here, you'll see that the two pull boxes right there, which is what we call them today, are still in the fire code laws. So every building that goes up in the United States today has these pull boxes on every floor. And you'll also find them in schools all around the country and buildings above ground and below ground. And there's still very much a temptation for kids to pull and run. The blue phone on the right is what you'll find in many campuses today, all around the country, also in metro areas. When someone without a phone is in need of assistance, there's actually a phone in that box, and there's also a light on the top for any needs for service in the evening. Okay, this next one, and I'm almost out of the history part here, but in the early 1900s, insurance companies began to offer fire insurance to the building owners, and these same insurance companies were responsible for paying the firemen. And a little bit about this fire mark here I found real interesting, and I hope you do as well. It says these metal plaques marked with the emblem of the insurance company were nailed to the front of the insured buildings as a guide to the insurance company's fire brigade. Subscribers paid firefighting companies in advance for fire protection. In exchange, would receive this fire mark to attach to the front of their building. The payments for the fire marks supported the firefighting companies, and folklore has it that the volunteer fire department would not fight a fire in a building unless the fire mark was on the building. So hopefully that was not always the case, but a very, very different type of business there. And then a little after, last bit of history here, most of you that are in the public safety industry know all about the walkie-talkies, where they were first introduced in World War II, and they eventually found a home in public safety markets, allowing companies like Motorola and Harris and many others to commercialize the two-way public radio system, which they call a land mobile radio, or LMR. And the first project that Motorola put together was a P16 project, which was an analog system, and then later on came the P25, which migrated to digital, and which covers basically all the public safety frequencies today. And then a little bit about FirstNet, and some of the information about that is that there's been billions of dollars from the government to start a FirstNet nationwide public safety network with voice over LTE. Just as a side note, that's been going on for a number of years right now. I'm very hopeful that the government spending is the money spent well, and that this will take place. The general consensus between firemen is that it will eventually be part of every city across the nation, and primarily because it's critical for the firemen and the policemen and the EMTs that all of their wireless devices work inside the buildings. And as you know, many of the policemen now have cameras that they want to send over this voice over LT. So for emergency situations, it's very critical that all of them be able to talk inside the building, and that's called interoperability. So public safety today, it's a challenge. We have found in many cases that every building around the country is different. Every building doesn't have a basement. Some are high rises. It's just a unique environment. Even the architects are building buildings that are very different shapes, a lot of green glass so that signals from the outside don't travel into the building anymore. So you find people leaning against the glass or having to go outside to make a phone call. Fire codes were written to include architects and engineers and commercial developers and even building owners to get their feedback. And also installers, low voltage installers, so that the in-building wireless systems can be planned to be part of the building's ecosystem. And that would include many different wireless products. I've listed a few here, like carriers, facility radios, and with the carriers, you've got lots of different carriers that all operate a little bit differently. Public safety radio like EMT, police and fire, Wi-Fi, and even next-gen 911 for location tracking. But if you go into a hospital, you've got paging as well, and you've got telemetry. You've got nurse call systems, so many, many different wireless systems that all have to work together in the same building. And that's why the new building codes for IFC and NFPA have come out recently. I'm going to go over a few terms here with you regarding public safety. They're important for you to know if you're going to be in this industry or working with the industry. The ICC is one governing body. It's an international code council that writes codes for buildings and electrical codes and even fire codes and many other codes, but they do it internationally. That's basically meaning for the U.S. and all of for the entire world. The other one is the NFPA. It's the National Fire Protection Association, and they are actually only writing code for the U.S. So we'll take a look at that on the next slide. So I pulled this down from the web. This is one of the sites that I go to often to find out which state and which cities actually use which code, whether it's the IFC, which is the International Fire Code, which comes from the International Code Committee, or if they're using the NFPA. And anytime you're in the public safety space, those are the two basic questions you're going to need to ask any fire marshal that you're going to do a public safety job in their city. Is you're going to need to ask them, is this city using the IFC or is it using the NFPA code? And I'll go over the differences between those two here shortly in the upcoming slides. So when you look at this map here, you can see, and this is a surprise to me, the gray states, which are Florida, West Virginia, Maine, and Vermont, and Rhode Island, and Massachusetts, those are all using the NFPA, which is the national code for the U.S. And all the rest of the states, 42 other states, are actually using the IFC, the international code. So that was, to me, it was a big surprise when I uncovered this. You'll notice that some of the states are in solid red, like New Mexico, and then you look at Texas, and Texas is in a kind of a shaded red. And what that basically means, and you can rely on this, is that New Mexico as a state has adopted the IFC code entirely, and every city in that state has adopted it as well, and they are enforcing it. When you look at Texas and any of the other shaded states, you'll see that the state itself has adopted the IFC code for public safety, but the cities inside the state can adopt it or not adopt it. And the ironic thing about adoption is that you can adopt the code but never enforce it. And Dallas, Texas is an example of that. The state has adopted the IFC public safety code. The city has adopted it as well, but they're not enforcing it into the building owners. We anticipate that will change eventually so that every state on this map will actually be solid red or the solid gray. This is kind of a busy map chart right here, I should say, but this is the international codes by state. And I'm just going to briefly talk about this, but this is a very good guide to tell you what fire code they have adopted and what building codes, what electrical codes they've adopted as well. Now, this is updated almost every month. It's very accurate. If you take a look at the left-hand side and you see Alabama, and then you see the first column to the left, which is IBC, that's the International Building Code. If you go 3 columns in, it's the International Fire Code. And the S basically means that there's a statewide adoption in Alabama. And the 09 basically means that they've only adopted the 2009 code, which they're way behind on their code, but that's where they're at. And that's going to be important information for you to know, because that's what you're going to want to build your public safety network by, is that code. And you'll see the L basically means it's adopted by local governments. So I'm not going to stay here long, but there's a lot of information there, and we can even drill down to each city, which is very nice. I brought this back into view again because I wanted to have you take another look at today's environment in many big cities. There's so many buildings that just don't have public safety. If you talk to the code writing committee, which we have the opportunity of doing, they will tell you that eventually every building that's built, whether it was built back 10, 20 years ago or it's a brand new building, they're eventually going to require the public safety systems to be installed in them. So companies like Solid, we're working to drive our prices down so that can happen sooner than later. I bring this slide up primarily to show you that when there's a signal outside, whether it's a carrier signal or a public safety signal, and all public safety signal is actually on towers outside. There's none that I know of in any state that actually go through a fiber and into the building like a carrier would. But the public safety repeater might be 10 miles away, it might be 15, it might be 1 mile away. And that determines how you're going to build your public safety system inside that building. The next slide that I want to bring up is a very similar slide, but it was actually an exercise that we went through in regards to a building, which is the rectangle here. And then the dot on the left is actually where the repeater is. And if you look down by the example, it's actually 10 miles away from the building. It's pushing the public safety signal to the outside of that building. And it shows us that 10 miles away at a very strong signal, it hits this building at a 68 dBm, and that's just basically a power level. It's actually a very strong power level, but by the time it makes it through the first wall, the outside wall, it's going to lose 10 dB, or excuse me, 20 dB of power, which means the signal gets weaker. And as it goes through each wall, it gets weaker and weaker. And by the time it makes it to the either the other side of the building or inside the building, the portable radios for a public safety system is at a signal strength that you might be able to get a text out, but you won't get a voice out. And so then, therefore, it becomes a dangerous area for a police officer or a fireman to be fighting a fire in that area because they're not going to have any communication. So this is the very reason why the public safety codes were written. This is also an example that when you're putting a public safety system together, that you do need to find out how strong that signal is at the outside of the building. And if it's a weak signal there, you know it's even going to be weaker inside the building. So you're probably going to have to put your equipment closer to the outside of the building than deep inside. So there's a lot that goes on to that, but this is just a depiction that this is what happens, and that's why, from a sales standpoint, that's why people go to the glass to make a phone call. And with a lot of the new buildings, obviously there's green glass and there's other structural pieces that make it difficult for signals to come through. Here's some key dates right now that I wanted to bring up, and just some of the guidelines that we go by and we see with many of the people that we work with. In 2001, as you know, our Twin Towers in New York City fell, and it became very evident to everybody that public safety was a priority now, all around the world and especially the United States. Amazingly enough, during that time, the public safety codes were in process, but 8 years later, the first set of public safety codes came out and were released both by the NFPA and the IFC. Now, that was the first year that these codes came out. If I compare that to the electrical codes were in existence for 130 years, building buildings. And so you can see that the fire codes are a little behind. They're in their infancy stages. So they are changing quite rapidly. The code committee kind of creates their public safety codes as, hey, thou shalt do this. And they want each of the cities to adopt that. Not every city does, but that's the push. The codes are then turned into city ordinances. So if you hear about something called an ordinance, it typically was a code previously, and it has the same language. The ordinances are then enforced by the fire chiefs or the fire marshals. So if you go into a city and you don't know which code is being used, then we would advise you to go meet with the fire marshal, the local fire marshal, and ask them, what have you adopted? And can I have a copy of the code? The ordinances are dictated as a minimum amount of public safety that is required in that building. The fire marshal may say, hey, I want a stronger signal, and you'll need to comply with that fire marshal. But in most cities, you're going to find that this is becoming mandatory, not just an option. But in some cities like Dallas, it is an option. In fact, it's not enforced. There is a requirement that in many of the new buildings that are 4 stories and above, they do need a public safety amplification system before those doors will open. A few things that have to be, that are on the code requirements are battery backup systems for amplifiers and public safety BDAs. The public safety alarming piece, you saw those pull boxes that were on the first couple of slides. Well, it's different now. It's dry contacts that will indicate that there's a loss of power, or the BDA is no longer pushing the same type of signal strength, and that type of alarm will go right back to the fire department as well, but those are mandatory. The NEMA 4 enclosures, which basically means that you can actually spray a fire hose onto those devices, and they'll keep on working. Everything needs to be in a NEMA enclosure. After you put your system into a building, or there's a system in there, you do a grid walk test with the fire marshal and the AHJ right next to you, taking voice signals to see how strong the voice signals going to dispatch and coming back are. And then also they look at the signal strength itself. And then finally, there's final documentation that's required. And all of those grid test walks that you took, and all the DVM levels and all the voice quality levels are recorded. And those are given to the fire chief, the building owner, and also City Hall. And monitoring is another thing that is required as well for all public safety systems. And after the system's installed, the ordinance requires a yearly testing to make sure that the signal hasn't been degraded. And of course, for any new building, the goal is for certificate of occupancy. This is a comparison. This is that chart that I was telling you about that I would show you between the NFPA 2013, excuse me, and the IFC 510. So on the left-hand side, you'll see that there are some key areas. I'm just going to run down these quickly, but we're probably going to need to pay most attention to the IFC unless you're in one of the gray states. Antenna malfunction is literally the antenna on the roof that pulls in the signal. If there's an adjustment change or a wind change that causes that to topple over or to move, that'll be noted, and the fire marshal would get an alarm. A signal booster failure, that's a BDA. That might be from a company called TXRX or Axel Wireless, something like that, G-Wave. And if their BDA that feeds into the building fails, the fire marshal would also be alarmed, and that has to be alarmed. Everything, as you might, that is active in that building for the public safety has to have a UPS battery backup system. And in there, there is a battery, and if the battery goes below 70%, then there's an alarm that goes off. And the next one down is if the AC is lost in the building, you'll get an alarm, and that'll go to the fireman. And failure for the battery charger, if the charger's not working, you're going to need, you'll get an alarm as well. Backup duration, this is basically saying whatever equipment's in that IDF closet. For NFPA, you have to have it backed up for 12 hours. For the IFC, it's required twice that amount of 24 hours. The coverage side, and let me say a point about the battery backup. For the building owners that might be on this call, the big thing here is that you need to know the public safety equipment that you're using. You need to know how much power that public safety system is taking, because that's going to determine how big the battery is for 12 hours or for 24, and how much weight that's going to be in your IDF. And usually there's not enough space in those areas, and then another solution has to be provided. So that's one very big consideration for building owners. And then there's a coverage requirement. For NFPA, it's almost 99%. It's NEG 95, and for IFC, it's only 95% of the building. There's monitoring and maintenance that's required, which basically means you can see what's going on with the system at all times. And if something fails, that somebody is assigned to go fix that. And the battery backup cabinets need to be in a NEMA 4 enclosure as well. This is just kind of another slide that just echoes what I just said. It's just in a different format. So you have the IFC and the NFPA at the top that's monitoring all active components. Any other components needed simple dry contact. And all the blue around there were basically the alarms that needed to be alarmed for the fire department. This is a slide I wanted to primarily bring up for the building owners. There are AHJs to this. There are integrators. There are low voltage companies as well that they're going to be pulling cables. But for the building owner, the thing that I'd like to say here is just to make sure that if you're putting a public safety system in your building, that you choose a good DAS integrator who understands both carrier and public safety needs and has the experience. If you're in California, make sure they understand the OSHPD requirements for hospitals. And on the AHJ side, the big thing there is that you can find out who the AHJ is simply by going to the fire marshal and asking who that person is. It might be the fire marshal. In most cases it is. The fire marshal can typically be found either in a local firehouse or they're at City Hall. And with the wireless industry, basically the integrator to us is a very key part here. Make sure that they are certified Make sure that your equipment is UL and FCC approved. And also from a design standpoint, there's a lot of different criteria that is going to be needed to make sure the design is done correctly. But knowing those public safety codes and understanding the frequencies that need to come in and out of that building are critical for that design. This is some of Solid's gear. These are two public safety pieces of equipment that we painted red, just so that the firemen would know that that's their equipment. It's also an indicator to the reseller that might be in there repairing things that they shouldn't be touching the red units. Our head end unit, which is the white one down here, literally has to be put in a NEMA 4 enclosure, as anything that's not NEMA 4 would have to be in a public safety environment. Okay. This is just an example of the same equipment with our head end. A public safety system would feed the head end, and we turn that RF into light through our ODU product here, and then one single strand of fiber goes to the first unit, which is the upright unit, which is a 7800 public safety, and then we pigtail that to the 150, 450 system in that building. Both of the red units are NEMA 4, as I mentioned, and we've designed these things so that they would be easy to install. Some of the things that we've done, and I want to move along here a little quicker, we've created an easy set button so that when this is installed according to the design, you simply go ahead and easy set, and each one of those remotes are actually configured automatically and set up. We have improved firmware so that you can do backup and restores. We have real-time reporting as well. And we have a very unique system for remote management and monitoring called Halo, which maybe I'll do on another one of these G2 talks. I won't go through this much, but this is basically if in a public safety or any environment where there's something down, we receive a call from our resellers. We create a trouble ticket immediately. An RMA is put into request, and an advanced shipment is sent out the same day with an envelope to send the equipment back to us. But with public safety environments, it is a critical environment. I brought this up because there are differences between the cellular needs and the cellular coverage. And you can see that public safety and cellular here have different frequency bands, which are at the bottom, but they do have some similarities in how much space needs to be covered. And the real difference there, I think, is in the design parameter where I say neg 85 dBm and 95% for cellular, but in many cases it's much stronger than that. Just to go quickly through this, I wanted to show you, in case you're in any of these markets, these are some of the environments that we see public safety as being an absolute must. And in most of these environments, especially like the sports arenas, we're not only going to have public safety in there, but we will have a parallel system where the two of them don't touch each other. We'll have both public safety and we'll have carriers on two totally separate systems. Neither one of them want to share anymore. So for the building owner, those are two systems that will run independently. Another environment that we find a lot of success in is higher education. Stanford University, I mentioned that a couple of times. You can see the massive amount of work that has to be done with 600 buildings. And the amazing part about, I know, Duke and Stanford is that every one of these buildings has a tunnel underground that leads to it. So there's tunnel work that has to be done as well. But great projects, wonderful projects. Healthcare, as I mentioned, we do a lot in healthcare, primarily because our OSHMOD expertise, then even for enclosures as well. Here's some of the ones that we've worked on in the past. Certainly not a complete list. Hospitality, from hotels to casinos, to the arts. Usually includes big buildings. Large casinos are a huge challenge. Transportation, like airports, the New York subway is one of our projects as well. We're covering all 255 boroughs. Major project for us, but it's both public safety and carrier signals there. And we cover the tunnels as well, where the trains are going. So if the train was to stop in the middle of a tunnel, there would be carrier signals down there as well as public safety. Lots of airports as well. Many of these are homeland security threats, and so public safety is paramount. With enterprise, obviously, public safety is important there as well. There's liabilities that go on there, but also just a tremendous amount of data traffic that goes on, and companies like Amazon and Google and Boeing, and just to name a few. And I think the last couple ones here, also obviously government buildings. We do a lot of work in Washington, D.C., very difficult buildings to get security into and out of, and working permits, but a lot of work does go there, and statewide as well here in California with our state capitol. And I wanted to leave a couple things with you. We have 6 different territories throughout the United States. We have salespeople, which this is a list of all our salespeople that support all of the Graybar offices and all of our customers in those states. And with each of those salespeople, we also have an SE. And the SEs in these territories actually have the ability to do one-day trainings and travel with their salesperson as a team, and are here to support in any way that they can. My last slide is basically my name on here, and also Matt Atkins, who works with me on the public safety side of our business, and we're here to assist in any way as well. Our goal is really to try to get back with you as soon as possible, and our goal is to pick up your call when it comes in. We know that people are very busy today, and it's our goal to provide the best service in the business. So that's the conclusion of my webinar today, and I welcome any questions.
Thank you, Bob.
Back to you, Melissa.
Thank you, Bob. At this time, we'd like to address some of the questions that have been submitted. As a reminder, you can submit a question using the Q&A box at the bottom of your screen. If we don't get to your question, a Graybar representative will follow up with you after the presentation. So the first question we have, are the wireless applications to override public address systems for emergencies such as active shooter scenarios?
Would you repeat that? Yeah, would you repeat that question one more time?
Are the wireless applications to override public address systems for emergencies such as active shooter scenarios? So is there anything in there that's going to allow one system to override the other?
Not at this point. Our systems are designed to actually work in conjunction with each other, and that was kind of the ecosystem that we talked about earlier. In an active shooter environment, which unfortunately last year there were 2 incidences in malls. The key thing that has to take place in that environment is typically the phone call is going to come from a cell phone. So that cell phone needs to get out of the building, and there needs to be a response coming back in from public safety, from someone in public safety. It's typically dispatch to that person, instructing them what to do. After that, then the police, fire, and the EMT would come in, obviously the police first, or the SWAT teams, and those groups need to be able to talk to each other in those environments. But I hope that answers your question.
Okay. Another question we had, the code requires reporting of the various components of the in-building system. Where do they report to, and who builds the necessary infrastructure on the local government level?
On a local, okay. So the codes actually the required codes are adopted by the city, and the building owner is obviously responsible for having that paying for the public safety system that goes into the building. A reseller, a certified public safety reseller, would be responsible for putting the design together to go into that building. They were also responsible for making sure that the public safety signals can reach that building in the first place, and then they would be the ones that would be actively putting that system in. Once the system goes in, then it's the fire marshal that will walk the building with them to determine if that building meets the code requirements and the signal strength requirements stated out in the code. If they don't, then you redesign that building and you do it all over again.
Okay.
Okay.
Another question. You mentioned that the carriers and the public safety systems don't normally want to share their systems or run on those two systems don't run together. Is that for maintenance? What's the reasoning behind that? Are the carriers looking at adding a public safety aspect?
The answer to the last question, the carriers are not looking to add a public safety aspect there. Although with FirstNet wants to use the 700 LTE piece when they're the carrier when there is a public safety incident. Since FirstNet is not too far off the ground at this point, that's just the intent. In regards to, and we'll see if that happens in the future, but they're looking to use the carrier LTE area of the spectrum when there is an incident that's taking place, and they would have priority over that. In regards to parallel systems in the building, companies like Solid actually have products. Our products will allow both of them to go into one cabinet, and you can have public safety and carriers. But the way the code is written today is that the system needs to be backed up, that we need to ensure that if anything goes down, it is that there's a way to bring it back up. And so the easiest way to do that, and we found the carriers from a public safety situation in general, they would prefer that they be on their own, and they don't want public safety bringing them down, and public safety doesn't want the carrier bringing them down. And if you've done any jobs in a building before, you'll know that once you put the carrier system in, the carriers are going to be coming in there to tweak different things or do something to their system, so they're always doing something, and they might even power a remote down if need be, and in doing so, you're obviously powering down the public safety at that time as well. So that is one of the key reasons why public safety and carriers are running in parallel systems.
Thank you. Looks like that's all we have at this time. I want to thank everyone for participating in the call. Please do know if you have questions later. We got another one came in. One more, Bob. Do we have time for one more? How are the system monitoring? Okay. How are the system monitoring alarms reported to the fire official? For example, a BDA failure. Right.
So the BDA, I'll use the BDA as an example. The BDA, let's say it's a public safety BDA, has a dry contact on it. I don't know if you've seen a dry contact before, but it's basically simply a two connections to a wire, and that two wire actually goes back to, it's plugged into the BDA, and that BDA is designed so that when power does fail, that it either closes that connection at that dry contact, or it opens it, and that cable that's plugged in there, it's just a real small little cable, actually runs all the way back to the fire panel, or there's an auxiliary fire panel that has as many as 64 different dry contacts on it. That dry contact is assigned a number, and back at the fire station, they would know that in, let's say, an Apple building in Cupertino, we just received an alarm that there's a problem with the public safety system there. At this stage of the game, the fire department does not want to know that, hey, it was a battery, or that the UPS 70% low battery alarm just went off. They don't want to troubleshoot it down to that level. They just want to know that there's a failure and that they know who to call in order to indicate that there is a failure and that it's being fixed. Okay, so it's a real simple little dry contact.
Thank you, Bob. Well, we're about out of time at this point, so if we didn't get to your question, we'll have a Graybar representative follow up with you after the presentation. As a reminder, this presentation will be archived on the graybar.com website. And again, thank you for your time today, and we hope that you'll join us next month for Graybar's next G2 Talk. Thank you.
Thank you.